my basic point of coming and speaking to you was to just tell you a story of two kinds of research or exercise activities that we have been doing in our department. And I will tell you about two, like the title of my presentation says. I will be telling you about modeling and the study on degraded areas. So I will first outline the one thing, give you an example, then I will outline the other thing, and follow up with an example. Very, very briefly, we come from Wrocław, which is a city of 700,000 inhabitants, roughly. On top of that, we probably have between 80 to 130,000 students. So for 9 months out of 12, Wrocław is a very young city. There are several universities, state universities and private as well. We come from the Wrocław University of Technology, Faculty of Architecture, and in our department, in which we are PhD students, there are multiple fields of research, such as urban or city planning, any way you prefer, regional planning, legal issues, modeling tools, which I will be mentioning, sociology, participation, as you've heard just a second ago, planning management and administration issues, being the main topics. Our department is also active in teaching, and spatial planning is an independent discipline of university studies in Poland since 1996. And the head of our department, Professor Cipser, who, by the way, has a little bit of affiliation with the Czech Republic and Prague academic community. Our head of department was belonged to the group that actually had made it possible to include spatial planning, to give it autonomy. I would also like to mention that a large proportion of our older colleagues are employed in various professional, public or commercial entities, such as Kasia mentioned, that our friends working in Wrocław Development Office. So, for example, I'm referring to them. People in the local authorities, in the urbanist and architecture chambers, and so on. Now a word about the intervening opportunities model. You may have heard about that. The origins of modeling in planning are most frequently traced back to cats. And I don't mean the animals, only the Chicago Area Transportation Study back in the 50s or 60s, I believe, in the United States. And it has been developed in a couple of different ways in a couple of different places around the globe. In Wrocław, it was Professor Cipser who was very active in working on this in this discipline. So the model allows for estimation of flows of travels, and you have my explanation. By travels, we mean journeys, trips from a given origin to a given destination. So, for example, from home to work, from home to various services, from those services to home, and any other thing you want to come up with to try to analyze. The model assumes origins and destinations while enabling manipulations, and I mean for experimental purposes, and to put it more informally, the positive meaning of the word manipulations. So you can, as origins, you can understand, for example, how the number of people that live in a certain area. But you can change the numbers any way you want, as long as it's viable and defendable. The main and the most interesting parameter that is used by the model is so-called selectivity, which is a smarter word for actually to what extent the travel makers are choosy. In other words, how likely they are to be satisfied in their trip at certain given opportunities. So, to put it extremely simply, if I leave home to buy bread, I'm quite likely to stop at the first bakery I encounter, but if I leave home to buy a grand piano, it's quite possible that I will look in 10 different places to choose the best model for the best price. Yes, and the model requires a route network, which, again, could be anything you want it to be. It could be simply streets, could be public transportation, railroads, or walking paths. Anything you want to work with. I will get back to this slide. I forgot to move it to the other half. It will be clearer if I stick with the intervening opportunities model for now. So, we've done what I like to call an exercise study using this model concerning Wrocław, and actually one specific site in Wrocław. As you probably know, Wrocław was one of the host cities of Euro 2012, and just before that, we had some major investments going on in the city, mostly in the Department of Infrastructure of various kinds. So we got a new stadium, the motorway bypass, which was very, very needed. So the Euro 2000, the Cup, the football cup, was one of the major motors behind the fact that we actually got funding from the EU, from credits taken by the local authorities, from the central government. Right, and I will be telling you about the Western Pole. So we'll see on the map in just a second. Wrocław is a very monocentric city. If you ignore the numbers 2 and 3 for a second, Wrocław is a very historic city, and it's really, really concentrated around the historic center. This number 2 is what we sometimes refer to as Southern Pole, which is one of the, honestly, one of the largest in terms of surface area, largest concentrations of large-scale retail. And it's a motorway crossing, so this node has become extremely important, although few people live there, as residents, I mean. And now, this is the route of the motorway bypass. Here, the authorities of Wrocław have begun the process, and it's actually, I would say, not only a spatial but also a political decision to possibly decentralize the city a little bit. The Western Pole is planned as one of 3 major concentration areas of services in Wrocław. A major shopping center and some leisure and residential areas are also planned there. You have, in this place, the details of the map are not extremely important, so please don't mind the colorful map too much. This place actually consists of the motorway bypass, one of railway routes, and another major route outside of the city. Just as a digression, on this brand new stadium, which actually on this photo is still under construction, the Czech national team played the match against Russia, which they lost 1-4. I was in the stands, and from the top of my lungs, I supported the Czech Republic. So, about input data that we need for the modeling. Model of the analyzed area had to be prepared. You will see it in a second. A projection of the layout of the area, the road network, and the population quantities of the locations when necessary. And the data we got from the Central Statistical Office, the Wrocław Development Office, and Department of Spatial, from our own resources. This is the Wrocław agglomeration, roughly a 1 million people region of over 3,000 square kilometers. For the study, we divided into 348 districts, which are not the same as administrative districts that are over there. these are our regions, because out of this, say, 1 million people, 700 or 750 are there in Wrocław. So Wrocław actually comprises of 310 out of the 348 regions. This is our road network, which is valid for a year back from today. There are 6 sets of speed. That's the population density, which is quite understandable. These are minor towns outside of Wrocław, and that's Wrocław, that's the city center. Right, and one thing about our modeling is that we only, what we wanted the model to do is to allow for all people from all origins to travel to services. However, we only allowed these travels to 3 points: the city center, the southern pole, and the western pole. We wanted to confront these 3 locations. The software we've used was obviously the GIS systems, and it's modeling out an ArcView. Yes, we used the intervening opportunities model. For example, setup of the simulations. That's the selectivity scope. Obviously, the shear number does not have to tell you anything. It's calculated from a formula which, excuse me, takes into account just a couple of factors. It's actually much less complicated than it looks like. For example, the parameter of maximum contact range is how long you allow the people to travel. Intensity in this case can be excluded. In simulation A, we confronted the three poles, and in simulation B, we even excluded the city center and only confronted the south and west. For example, in simulation A, we allowed each of the three to absorb up to 100% of all travels. The first simulation was interesting to the extent that the city center absorbed 100%. So, because of the population density and because of the road network, and despite the 2 motorways, the city center attracts as much as it possibly can. Then we blocked the city center to an extent. I think it was 50% or, yeah, 50, I think 50. So the 50% of all inhabitants of the area were actually blocked access to the city center, and then I had to choose between the southern and the western pole. The simulation pointed to the slight advantage of the western pole. Yes, I think I'm not missing anything. Just shortly to comment. The first simulation was made to see how much the historical center dominates, and the result was that it dominates totally. We also manipulated the selectivity parameter a little bit, so we changed our travel makers from choosing freely to someone actually quite likely to be satisfied. So they needed less to make a longer journey. They were more likely to stop earlier. In simulation B, we limited the city center first to 1/3 of all travels, and then to 0. And the simulation in both cases showed a slight advantage of the western pole over the southern pole. To comment shortly, I've said that already. Just a short comment about the modeling itself. As you can, as I've written here, the model serves to analyze a limited fraction of real-life situation, and much data was rounded or overestimated, which is why we called it an exercise study. It does not aim to provide any percentages or numerical data, only tendencies, so to say. Right, now I will just shortly get back to degraded and outdated areas, a second study we've been doing. This actually I mostly refer to work of a friend of ours, but in post-communist, everywhere in the world, in every city obviously, but in the post-communist countries we have to deal with quite a lot of areas, plots or parcels, whichever you like, which have lost their function. And they lost it quite recently. 25 years is the maximum. These areas have various origins, and therefore studies on them could be actually allow for a broad spectrum of approaches. What we've been doing at our university is categorizing the degraded or outdated. I will reuse these terms interchangeably because actually the Polish word we've been using is closer to what English language would call outdated areas. So a typology has been built. For example, the outdated areas could be divided by their origin, such as industrial, port areas, railway areas, post-military areas, or unused waste urban fabric. They could be categorized by their size, which is probably the easiest categorization, or outdatedness, so to say, type. Functional, material, moral, and compositional. Shortly, functional when the function of the area, the mere function has become outdated. Material, so when the physical, the buildings have actually deteriorated. Moral, a very interesting category, is when the perception of the users of the area has deteriorated so much that they don't use it anymore. And compositional is when, generally when other developments have lowered the quality of a certain area. Another categorization is location, such as distance from the center, or accessibility from various types of transport, or what neighbors such degraded, outdated areas. It could be divided by what land use is or was, by who owns it, and by transformation dynamics, meaning who has been using it throughout the history, and transformability, which is a rough term for how much success we can project for an area, for a given area in the future. Once again, I apologize. I should have moved this one slide to the place where I changed the topic. Yes, and I will only, for 5 slides, I will show you examples of maps. This map, forgive me for Polish key, that's the origin of areas. So, for example, in violet, you've got post-industrial, generally, post-industrial areas. In light green, such as here or here, you have post-military, and for example, in red, you have post or even current railway areas. As you can see, even if the map was in grayscale, I believe that that's quite a lot of area inside the city. These are only plots that are over 25 hectares. Again, that's quite a bit of area. These are 20-minute walking zones from the market square. So here we've got distance from the heart of the city, which, as I said earlier, is quite monocentric. These are 80 and 100 meter buffers from vehicular traffic, so roads simply. As you can see, this, just for example, this area is a former. It's a mixture actually, but this is a huge area of allotment gardens. So you can imagine that this is actually a hugely autonomous enclave inside the city. These are 320-meter distance from railways, although not from railway stations, only from the tracks, the railway line. And just to wrap it up, types of neighboring areas. For example, well, obviously blue is water, but the dark red are residential areas. For example, we even have arable land, mostly here, or any interesting case, forests even in here. And that would be it. Thank you. I hope it wasn't too long.
If I understand it correctly, and I'm very bad at all of this, but very impressed, this is giving you a current state situation. What is the time horizon? This is like you use this and then you look at the situation and say, this is what it is like now.
Okay.
That means what as a tool does it actually do in planning? Because if it gives me a state now, can I then adapt it to say if I have bike lanes here and there, what would happen? That's the question.
So I would say answer in two ways. First, it can show you whatever you want. Not in the way that but not in the way that you can skew it.
Okay.
But you can model anything you wish. But that's a less important answer. More importantly, that in most cases it is used to project future. Or, as I said, that it's only a model. Okay, I didn't say it. Monty Python said it. It's only a model. So it cannot be trusted too much. But if you, for example, design a new network connection, so a new road, say, and you want to check to what extent it will relieve traffic jams in a certain area of a network, you can do that using this model or advanced versions of this model.
Thank you.
Is that enough?
Absolutely.
Okay.
Very good question. Do you know about any recent use in Wrocław, because you're talking about Wrocław, that, for example, Wrocław Development Office is using modeling tools to support or to justify any urban ventures?
As far as I know, without going into much detail, because our audience does not know our city, but I think when we were introducing the more intelligent tram, the three new tram lines that were introduced, and they were supposed to be intelligent in terms of being advantages on crossings. So when they approach a crossing, red light for cars turns on and they pass. I think that then in the process of designing these three routes, that was introduced, where the first traffic should be relieved the most, and to where the tram plus should stretch. Because just explaining, it is mostly 2 out of 3 lines are based on huge concrete blocks estates. One that houses like 30,000 people, and the other, I would say again 25, something like that, and goes through the center. So, as far as I know, for example, with that, they have been modeling.
And I have, when I go from home to work, I can choose a bus, tram, and metro, or combinations thereof, which is, I think, part of the legacy of the period of time that we're talking about. And one of the things that I witnessed in Prague, coming here for 14 years, is this shift. It's not to say that public transportation is no longer given a priority, but there certainly is a major priority on supporting private automobile transportation. And I'm curious in your modeling how transportation systems affect this choice between the Western Pole and the center. You've decided to, in your modeling, to simply cut those connections in order to be able to differentiate the southern and the Western Pole. Rather than cut that, is there a modeling that you could do to see what critical mass do you need in order for there no longer to be that 100% concentration on the center?
I think that's a great question, because now, I wouldn't even say I've been thinking about that. It's been discussed. Yes, I'm pretty sure that such model could be built and then run to calculate that or estimate that. However, first of all, it would be really, really complicated and would need quite a lot of work. And it has not been properly done so far. I do hope it will be, and if I have the chance, I will engage in such works. The model has some limitations, obviously, but I believe it can be done. In our exercise, we only use the road network, so that's it. Which does not necessarily mean private transportation, but we only limited ourselves to roads, per se. And one thing, and from the other side, answering your question, you're quite right. I think it's a very deep sociological and psychological issue, because Poland has, in Poland, it's been, I don't know how to put it nicely. I would call it plague, but it's maybe too much. Overwhelming increase in private transportation, and I refer to it as sociological or psychological, because I believe that after being deprived of much of private property for 45 years, these post-communist societies are now indulging in owning as a philosophical phenomenon, owning. That's why what Kasia was referring to, that the belief in common good is, well, not satisfactory, especially to planners. That's why plenty of people are not even aware that they could move around more efficiently in another vehicle than their own car. Well, and so on. That's a hugely broad topic.
Thank you. Yes.
Just following your question, do you have maybe an idea or maybe knowledge about how this model could be used? Is it possible to mark the difference between public transportation and private transportation? Is it possible to make a difference between them, or to give a priority to one of them?
I have an idea. I don't have the actual knowledge, but actually, we could discuss this topic for a very long time. But simply, I think you should have two overlaying networks, and you should have yet another sub-parameter on the possibility of changing on the nodes. Right? So you can switch from. So a sort of parameter that would make you choose the transport mode at the beginning of the journey and in each node on the journey. Maybe that would be the solution.
A very short question. How good this model would be for people who want to buy a flat? So how much it can model also their different factors of human to choose a flat. And one is for transportation also. So maybe it can be used for value a flat, how much it worth in this factor.
Real estate value
factor.
Yes, I think it could be used for that, especially with connection with such geographical analysis as I was showing in the second example.
The second one.
Yes, the merger of the two. It does not have to be limited. Like I said, you can model various types of travel. So you could run a simulation for taking your child to school, then next one for your child going to school on their own, then another one for your travel from home to your work, as opposed to taking your child to school first. You could add more data such as, I don't know, for example, there is talk, and I support it strongly, that we should have a river tram, because there is plenty of river, the river, it stretches, meanders, and we have some canals, 400 bridges and so on. So, for example, if this tram is finally there, how that will change the situation. I think it could be used for real estate appreciation.
Okay, thank you very much.
Thank you very much.